We want to know the true population proportion of Irish Americans who approve of a wider representation of groups. This was a big deal back when I first made this problem. If you remember the issue of gay, gay groups marching in the parade. I think they march in the parade now, don't they? Right? Do they have gay groups in the same pattern? Am I wrong about this? Right? They do now, right? They still keep them out, or they do now? They do now, yeah. Okay, suppose we want to know the true proportion of Irish Americans who approve of a wider representation of all groups in the St. Patrick's Day Parade. In 2000, the parade committee asked for a random sample of Irish American parade participants if they approved of wider representation. Out of 1,381 respondents, 496 said that they approved. Okay, so let me get a fresh piece of paper here. A fresh piece of imaginary paper, I mean. Okay. Okay, so let me work on this. Okay, what do we got here? So we had, how many did we say we had? We had a sample size of 1,381. And how many approved? 496. So what is our point value here? It's not the mean, right? It's the proportion, right? And instead of calling it P, what did we do when we were talking about the mean, we took X, put a bar over the top of it. That indicated to us it was a sample mean. So to indicate that this is a sample proportion, not the population proportion, I'm going to put a cap over the top of that. See the cap? That means sample proportion. So what is that proportion? Anybody calculate it yet? 0.36? You're invited to all of my classes from now on. Okay, any class you want to show up for, just turn up. Okay, 0.36. Okay, so now we know we know a sample size. We know our sample size justifies using this idea of the z-score instead of going to a t-table, right? Big sample size, sufficiently large, yes and no, for a proportion, or successes and failures for a proportion. Okay, so now what do I need to know besides that proportion? I know I'm going to use 1.96 for our z distribution for a 95% confidence interval. Okay, what else do I need to know? I need to know my standard error so I can calculate my margin of error, right? So how do I calculate my standard error for a proportion? It's equal to the square root of, anybody remember? Times 1 minus p. Right, all of that under the square root sign. That's all they're going to work that out first, and then find the square root. Now, sometimes some equations you'll see p times q. Q is just another representative for way of representing 1 minus p. So don't get fooled by that. So that's going to be equal to the square root of 0.36 times 0.64, right? That adds up to 1, over the sample size is quite large, 1381. Okay, so let's do that calculation here. See, now I'm rushing because I want to get it done ahead of you. 0.36. Now you got my competitor's juices going. 0.64 divided by 1381 equals. Okay, that's the inside of that square root. Right? Now, looks like a very small number. But because the square root is a number the square root, that number is the square. The square root is what the number which when multiplied by itself will give you that number. So the square root is actually, in the case of a fraction, larger than the square, right? So when I take the square root of this, it's going to become a bigger number. Okay, so now it's actually 0.0129. I'm going to call that 0.013, 1.3% basically, right? 0.013 is 1.3%. So I'm going to call that 1.3%, 0.013, right? So my standard error is equal to 0.013. So what is my 95% confidence interval for the true proportion P? Well, it's going to be equal to 0.36, right? Plus or minus 1.96 times 0.013. So that's going to get even bigger now too. My margin of error now is going to be 0.36 plus or minus 1.96 times that number. As a matter of fact, I still got it there, so I can say times 1.96 equals 0.025. 0.025. That's my margin of error. Those two numbers multiplied together. So my 95% confidence interval is going to be 0.335, right? To 0.335 to add 2.5% to that, 0.385. Right? In other words, 33.5% to we're 95% certain the true proportion of Irish March, of all the Irish marchers, is going to be between 33.5% and 38%. So what does that suggest to you? That suggests to you that at that stage in 2000, not today, we're 16 years later, a lot of things changed in the last 16 years, right? At that stage, 16 years ago, less than 50% of that population didn't approve of opening the parade to other groups, right? So that tells us something about this. It's a tool for us. Okay, so we use the idea of margin of error, standard deviation. Very similar here, standard error, very similar in proportions as we did to, we use them in when we're talking about when the point estimate is a mean instead of a proportion. The main difference was the way we calculated the standard error and some of the assumptions that we had to make. Okay, but otherwise we handle them pretty much the same way. Okay, so now